So this is the sensitivity analysis example. Please set up your Excel spreadsheet like this. We have three cash flows in this example: a P for $60,000, an A of negative $4,000, and then a cash flow at year 12 of negative $9,000. N should be 17 years, not $17. And then we have an I of 5%. So first thing we're going to want to do is calculate the net present value of the project, or the equivalent annual worth, whichever one that you want to do. So we're going to do the present value. So the present value of the P cash flow is just going to be $60,000, right? Present value of A at year 12 equals negative PV. Our interest rate or discount rate is 5%. Number of years is 17. A is the payment, $4,000, and that's all we need. So right now the present value of this is negative $45,000, and then the present value of a cash flow at year 12 equals negative PV rate. Number of years, this cash flow occurs at year 12. Year 12. No payment, so we're going to leave an empty space for a comma. And then the future value, that's what this is. It's a future value of that. And this. So the NPV equals NPV of, sorry, we don't need to do that. Sum these three, right? They're all in the present now. So the present worth of this project is $9,892. Now what we're going to do is say what happens to the net present value of the project if each of these cash flows changes by a certain percentage. So what we're going to do, let's say that our P is equal to 50% of the original cost. What is the net present value if it's equal to 150% of the original cost? So since this is at year 0, we don't need to just count it back. So we got that times that. Let's get our dollar operator in there. And obviously half of $60,000 is $30,000. Okay, so now we have a variety of P's ranging from 50% to 150%. In this, we assume that the other two cash flows are constant. May or may not be true, but so net present value of the project is equal to sum these two, right? We calculated them, and this. Now we need to add our dollar operators again. And C4, lock in on those cells. So we can see that if our P is 80% of the original value, the project no longer has a positive net present value. A good check to make sure that stuff is going right is if the value at 100% is equal to your calculated NPV, right? That means that there's no change in the project. So if it's not, you did something wrong. All right, so now let's do A. So to calculate the present value of A, negative PV, discount rate, 5%, number of years, 17 years, payment is going to be A times percent of the original cost, right? Let's go ahead and do that. Get some dollar signs in here to lock the cells in the reference chart. And we've got that. All right, so right now equals sum this, comma, this, comma, this, right? The two cash flows that we locked are staying the same, and then the other one is going to be based on the percentage of the original cost. So C2 and C4 we're going to lock. NPV. So you can see if A is ever at 130% of the value, it becomes negative. Again, we have at 100% the exact same NPV. And finally, let's do this for the cash flow at year 12. So equals negative PV discount rate. Oops. Number of years, 12, right? This cash flow happens at year 12. This is not a payment, so we're going to skip that thing and add a comma. And the future value is going to be this times our cash flow. Throw our dollar operators in there again. Go ahead and do this. We'll sum get the two values that we're holding constant here. And drag it down. Okay, again, 100%. All right, so this, how do you use these results? You can see that our cash flow at year 12 doesn't really impact the net present value's viability at all. It does impact the value, but not, it won't change if it's within 50 to 150%. And then these two, if they change, if the p-value ends up being 80% of its expected value, then all of a sudden we're losing money. Same thing with the A, and it end up costing 130% of what we're expecting, or 30% more, right? So how do you use these? So it's sort of up to you as an engineer to decide if, first of all, what an acceptable range for these percentages are, right? So you need to sort of examine how volatile the market is for whatever you're planning on purchasing or giving your money to, and understanding what an acceptable range is. So another thing that you can do with this is to make a plot. So let's go ahead and insert a chart. Do one of these, scatter with smooth line markers. So let's go ahead and, you can add data to it, select data. So we want the chart data range to be, let's go ahead and add a series. So this is going to be P, X values, 50 to 150, Y values are the net present value. Oops. Let's just go ahead and reselect that. There we go. You can see it plotted a line for us of the net present values over certain percentages. Hit OK. Let's add another one. Series can be called A. These X values can be here. Y values here. And you can see they cross at 100%. That's what we want. And then let's add one more for C at 12. Choose X values. There we go. Here's y values. There we go. Okay. So let's go ahead and keep that there. Can format all of this stuff however you like it. No reason to really have the other stuff, but there's a variety of ways to play around with it and change the axis ranges and everything. Anyways, you will see that they all cross at our NPV at 100%, right? The value is going to be equal for 100% of the cost. And then you can see that for the P, we want to make sure to add a legend to this. So see, add a legend. So there we go. Now we can see what our chart, what the colors applies to what cash flow. You can see that this doesn't really matter for assuming that our range is acceptable. For A, if the cost is too high, it will cross 0. Looks like at around 121%. And then for about 83% of the cost for P, then that also crosses 0 and our project is no longer profitable. So this only looks at single factors holding the other ones constant. There are other ways to look at multiple factors, but once you start looking at combinations of factors, it gets significantly more time-consuming and complicated. Anyways, thank you very much, and hope this was helpful.